Alright, good morning everyone, and welcome back to Chemistry Minutes with Mr. Rink, part 2 of our stoichiometry. And again, last time, if you looked at our first video, we did grams to moles, we also did basic stoich grams to grams. And now, finally, we're going to do stoich part 2, and that's going to involve what we call a limiting reactant. Alright, and that's very simple. You see, a lot of times if they'll only give you one number in a problem, then that's all you use. That's what's going to run out first, because it doesn't make sense if we have two chemical reactions, A and B. One's going to run out first. When that one runs out, the reaction is over. And so, again, that's what we care about. So that's why we need to use A in this case, because when that's done, it's done. So it just involves an extra step. So again, let's just take a basic example. We need a balanced chemical equation always. And so, but now, like the last one I gave you, let's say I just gave you 5 grams. But if I give you, say, 5 grams of something else too, now you get two numbers. And remember, you got to do grams to moles, do the stoich, back to grams. As we talked about in the last one, grams to moles is step 1. Do the stoich, which is just a ratio, and then back to grams. But now, in this case, before we can do that, we need to know which one's going to run out first. So there's a classic way to do it, where you convert both the moles, ratio of both, and the smallest one is it. But I have a little shortcut that I use, which is not in the book and not online much. And it's a two-step process. You just grams to moles and divide by the coefficients. You see right now there's 2 parts hydrogen and 1 part oxygen, and that's really important there. So step 1, like all, but make sure you label things, we're going to convert both to moles. So we're going to divide by the molar masses. Make sure to keep things labeled here. And so I'm going to divide by the molar masses of hydrogen, which again is 2 grams per mole. And oxygen is 16, but there's 2 of them, so it's 32 grams per mole. So again, dividing by the molar masses, and then when we divide by the molar masses, guys, it's really simple. So 5 divided by 2 is obviously 2.5 moles of hydrogen, and oxygen, 5 divided by 32, a big number, we're going to get 0.156. Now, right now, you can probably tell the limiting reactant. Right now, we're saying 2.5 moles, but there's a 2 there in hydrogen, so divide this one by 2 and this one by 1. And I'm going to write those numbers really small. 1.25 and 0.01, oops, 0.15. Now, you look at that and you say, well, which one is smaller? This one is smaller. We're not going to use that number, but that tells us that it's on a 1-to-1 basis. If we divide the coefficients, we're at a 1-to-1 basis. Oxygen is going to run first. So we're going to box our moles of our limiting reactant. Do not box this number or this number. It's a look-see. We just take a quick peek at a 1-to-1 basis. So we divide by the coefficients, 2 and 1. It's just a quick side calculation, and it tells us the limiting reactant real quick. Now we have our answer. 0.156 moles of oxygen. So we know that oxygen is going to be our limiting reactant. We know that we have 0.156 moles of it. When this runs out, it's over. I can now find water, or I can find hydrogen. I can find how much water was produced. I can find how much hydrogen was used. Or stoich, we can find either one of those. Let's do it differently. Let's find out how much hydrogen was used. You know, the last problem we did about how much was produced. But let's see how much hydrogen was used. And so let's take a peek at that. So we start, students ask, how do I start? We start with the thing we boxed. We start with our moles of our limiting reactant, always. And now what to do? Dimensional analysis time. We're already in moles. Some students want to divide again by the molar mass. We're already in moles. And so we're time to do the stoich, moles over moles. And again, we've had a theme in these videos. What's on the bottom, what's on the top, goes on the bottom. And that's how you don't get lost in a problem if you get confused. So moles of oxygen on the bottom, and we want to go to moles of hydrogen. Look at our ratios. Hydrogen's got a 2 by it. Oxygen has a 1 by it. So it's a 2-to-1 ratio. Look at that. Stoich is done. Now, we want to know grams, so we're going to do one more line. Again, what's on top goes on the bottom. Moles of hydrogen on the bottom. On top and on the bottom. And we, of course, we're going back to grams. 1 by mole. Molar mass of water. Oops, what did I do here? Moles of... Now see, Mr. Rink made a mistake here. I don't know if you see it or not. But oxygen's on the bottom. And we're going hydrogen on top. No, that's right. We're good. I'm sorry. Everything is fine. All right. And molar mass of hydrogen is 2. Okay. So moles to grams, do the stoich, back to grams. And all we do there is do our math. So we take 0.156, we multiply it times 2, we multiply it times 2 again, and we have 0.625 grams of hydrogen. Verbiage, instead of produced, we're going to go with used. And there we go. So once again, all we did extra there, we stood grams, moles, do the stoich, back to grams. We said add that extra step, convert both the moles and divide by the coefficients. We'll do one more practice video with some examples, and that should be on stoich. And thanks again for watching Chemistry in Minutes. Thank you.